Hi everyone, I'm Ankit Mishra. I have been teaching GATE experience for over 5 years for chemical engineering. So prior to that, I work at Vedanta Element and Power Limited. So I'm constantly creating PYQ series video for all of you. So I kindly request you to share the channel with your colleagues, and that will motivate me to create further video for you. So already I have uploaded lots of video from different topics of chemical engineering. So here I am just going to start with the second PYQ series of solution thermodynamics. So already I have uploaded one video where I have solved at least 20 questions. So here I'll be moving towards the next question of today's discussion, and here you can see, yeah. So I'll be starting with this question. So this is also very important kind of question. So let's start with the question for 9.21. So the question says that a fractionator recovers 95 mole percent n propanol as the distillate from an equimolar mixture of n propane and n butane. The condensate is saturated liquid at 55 degrees centigrade. The internal equation that has been given to you. So again, sometimes they will give you the internal equation, sometimes they may not give you the internal equation. So you have to understand these things. Assuming Rolle's law, you are supposed to calculate the condenser pressure. So before you are going to solve the problem, you should understand what is Rolle's law. So if I am writing y1 into pt, that is equals to x1 into p1 set. So this one is equation first, and again if I am writing y2 into pt, that is equals to x2 into p2 set. This one is equation second. So if I'll add equation first and second, so I can write the condenser pressure here pt will be equals to x1 p1 set plus x2 p2 set. So whenever you want to solve any particular problem, you should understand which kind of data that is being required to solve that particular problem. So here you can see in the question that mole fraction of liquid phase is given to you, right? So fractionator recovers 95 mole percent of propane as the distillate from an equimolar mixture of n propane, right? So equimolar mixture means x1 equals to 0.5 and x2 equals to 0.5. It is also given to you. And again, I mean, in distillate, it is recovering 95 mole percent of n propane. So if I want to calculate the condenser pressure here, so that is condenser pressure. So you are supposed to calculate P1 set and P2 set. So for P1 set and P2 set, you have to use the internal equation here, and the value of constant ABC is given to you. So if I'll calculate internal equation ln, let's say P1 set, so that can be written as for component A, n propane, right? So I'll be writing 9.1058 minus 187.426 divided by temperature is given to you, that is 55 degrees centigrade. So you have to convert in Kelvin, right? 328 and minus 25.16. So from here you can calculate the value of P1 set, right? And again, if you want to calculate ln P2 set, so you can calculate again 9.0580 minus 215.90 divided by 328 minus 34.42. So from here you can calculate the value of P2 set, right? So once you have calculated the value of P1 set, P2 set, then definitely the question is very easy now. So you have all of these data in your hand, and you can solve this particular problem while substituting the value of P1 set and P2 set here. That's it. Okay, I hope this is clear to all of you. Now I'll be moving towards the next problem, and the next problem is the mole fraction of activity coefficient of a component 1 in a binary liquid mixture are x1 and gamma 1 respectively. Ze is the excess molar Gibbs energy of the mixture. R is universal gas constant, and T is the absolute temperature of the mixture. Which of the following option is always true? So I mean, when we talk about Ge divided by RT, so Ze divided by RT, so that can be written as x1 ln gamma 1 plus x2 ln gamma 2, or sometimes Ze divided by RT can be also written as let's say ax1 x2, something like that. So when x1 tending to 1, x2 will be 0. So definitely From this equation this is not going to correct. So let's say ZE divided by RT when limit x1 tending to 1, which is not equals to 0. So this option will not be always true, and this will not be always true. When x1 tending to 1, when x1 tending to 1, so yeah, so limit x1 tending to 1, gamma 1 is equals to 0.5. This may not be true, so this will always be holding good. Okay, coming to the next problem. This is also very important kind of problem. So here you can see the question say that the value of PB by RT, that is equals to 1 plus PB by RT. So exactly similar kind of questions that I have solved earlier. So PB by RT is called as Z, that is equals to PB by RT. So Z is given to you and you are supposed to calculate, that is ZR divided by RT, that is equals to 0 to P Z minus 1 dp divided by P. Is that clear? So now if I'll substitute that GR divided by RT, that is equals to obviously 0 to P, and Z is 1 plus PB by RT minus 1, and again you have to write dp divided by P. So 1 and 1 will get cancelled out and P will get cancelled out. So finally you will substitute these things. You will be getting GR by RT, that is equals to PB divided by RT. Now if the value of B is given to you, residual molar enthalpy, okay, so you are supposed to calculate the residual molar enthalpy of the gas at constant pressure and constant temperature. So this one is the GR divided by RT. Okay, so you are supposed to calculate the value of HR. So if I want to write the value of HR, so that will be equals to minus T del of GR divided by RT divided by del T. So HR divided by RT is equals to something like that. Okay, we are supposed to calculate GR divided by RT. So now just substitute these things. So when I'll do the integration, that GR divided by RT, so that will be equals to how much? Del by del T of GR divided by RT, that is equals to del by del T of PV divided by RT. Is that clear? So that is equals to minus PB divided by RT square. Is that clear? So you can say that HR divided by RT, that can be written as minus T multiplied with minus PB divided by RT square. So T and T will get cancelled out and RT will get cancelled out. So finally HR will be equals to P multiplied with V. So pressure is given as 1000 kilopascal 10 to the power 3 and B is given to you minus 10 to the power minus 4. That is 10 to the power 6 multiplied with 10 to the power minus 4, that will be equals to 10 square, that is 100. So residual enthalpy change will be equals to 100. Right? This is as simple as that. This question was not very difficult, but this was a tricky question. In this question has been asked in GATE 2022 by IIT Delhi. Now moving towards the next problem of today's discussion, and again this question is really good. This question has been asked in 2022, and again in this particular problem you can see that excess gives energy that is given to you, that is your XA, XB, and obviously C1 plus C2 XA minus XB. Okay, and you are supposed to calculate that ln gamma A by gamma B dxa. So excess gives energy is given like in terms of a particular model, and you are supposed to calculate ln gamma A divided by gamma B dxa, integration of these things. Okay, so let's try to understand one thing. 0 to 1 ln gamma A by gamma B and dxa. So first try to understand what is ln gamma A divided by gamma B. That can be written as ln gamma A minus ln gamma B. And what is this? Ln gamma A by gamma B can be written as G1 Ga bar minus Gb bar. right? So partial molar Gibbs energy of A and partial molar Gibbs energy of B, second component, right? So when we have a molar property M, and M1 bar and M2 bar is the partial molar property of two components. So if I want to write dm by dx1, I can write directly M1 bar minus M2 bar. Is that clear? This thing. So if I want to write dz xs divided by del x1, so I can write za bar minus zb bar. Is that clear? za bar minus zb bar. So if I'll substitute this value here, so directly I can write that is 0 to 1 ln gamma a by gamma b dxa, that can be written as 0 to 1 del g xs by del x1 dx1 dxa. Is that clear? So there is differentiation inside the integration, so that will be equals to z xs, and that is equals to 0 to 1. So that can be directly substituted as obviously xa xb c1 plus c2 plus c2 into xa minus xb, something like that. So if you will do this integration from 0 to 1, xa tending to 0, let's say, and xa tending to 1. So when xa tending to 0 and x, so that will be equals to 0. Is that clear? Directly. So this, I mean, this question was looking very difficult, but you know, you should understand the tricks behind the question. So you don't have to calculate anything here, but if you know the, you know, funda that how to solve this kind of problem, this is the tricks that you can incorporate here. So you know, this question was from this particular formula. So if you know this formula, then definitely you are going to solve this question. Okay, so with that I'll be moving towards the next problem. This is also really a good question. So very frequently these kind of questions is being asked in the gate. So enthalpy H is given as 40x1 plus 60x2 plus x1 x2 4x1 plus 2x2, and you are supposed to calculate h1 bar infinity is equals to what? So in order to calculate h1 bar infinity, so h1 bar will be equals to h1 bar infinity when x1 tending to 0 or x2 tending to 1. So first you are supposed to calculate h1 bar. So what is h1 bar? h1 bar is equals to h minus h plus x2 del h by del x1. Is that clear? And since you have given x is equals to 40, x1 plus 60 minus 60 x1 plus x1 minus x1 square, and again 4x1 plus 2 minus 2x1. So I have just converted all of terms in terms of x2 into x1. So 40 minus 60, so 60 minus 20x1 plus x1 minus x1 square, and obviously 2x1 plus 2. So if I'll substitute these things, I can write h is equals to 60 minus 20x1 plus 2x1 square minus 2x1 cube plus 2x1 minus 2x1 square. So 2x1 square you can cancel out. Finally you will be left with x1 h is equals to 60 minus 20 plus 18, so 18x1 minus 2x1 cube. So finally you can calculate del h by del x1 also, that is equals to minus 18 minus 6x1 square. So finally from here you will be able to calculate h1 bar is equals to h. So that is 60 minus 80x1 minus 2x1 square plus x2 into del h by del x1, so minus 18 minus 6x1 square. But you are supposed to calculate h1 bar infinity, so when x1 tending to 0, so that is equals to, in all of these things you can say that will be 60 x1 0 0 0, that is 0, so plus minus 18, that is equals to 42. So h1 bar infinity will be equals to 42 here. So this is there is only one concept that you should know, that if you know this formula, definitely you are going to solve this particular problem. But again, when it comes to this formula, I mean, just PYQ first of solution thermodynamics, if you will see that video, there I have derived the formula in a very simplified way. In only 2 to 3 steps, you will be able to derive this formula. So you definitely, if you are solving any question in solution thermodynamics, you should know this formula. This is very, very important formula. This is the heart of the solution thermodynamics. You should know. Okay, now moving towards the next problem. This is just based on some kind of models in obviously solution thermodynamics. And in a binary mixture containing species 1 and 2 in the form of azeotrophs. So when we talk about azeotrophs, so liquid phase composition will be equals to gas phase composition. So this is the definition of the azeotroph. Is that clear? And the azeotroph is being formed at 105.4 degrees centigrade and so 1.013 bar pressure, and the liquid phase mole fraction of the component of this azeotroph is 0.62. Okay, so liquid phase composition of component is given to you, that is 0.62. Liquid phase composition is here, and the pure component vapor pressure for species 1 and 2. Okay, so P1 sat, that is given to you 0.878 bar, and again P2 sat, that is equals to 0.665 bar respectively. Assume that the vapor phase is an ideal gas mixture, then the Van Laer constant A and B are given. So the value of Van Laer constant, that is 1 plus x2 ln gamma 2 divided by x1 ln gamma 1, and this is the whole square, and the value of Van, and again here ln gamma 1, and B is given as 1 plus x1 ln gamma 1 divided by x2 ln gamma 2 whole square ln gamma 2. So the activity coefficient under these conditions are, okay, so you are supposed to calculate the activity coefficient under these conditions at the azeotropic condition. Okay, great. So when we talk about the activity coefficient under this condition, so I can write y into pt equals to gamma 1 x1 p1 set. So if it is azeotroph, so y1 and x1 will get cancelled out. So the total pressure pt is equals to gamma 1 and p1 set. So what is gamma 1? That is equals to pt divided by p1 set. And what is pt? So total pressure is given 1.013 bar, that is 1.013, and divided by what is p1 set, that is 0.7878, 0.878. So here that will give you the gamma 2, and again gamma 2 will be equals to obviously pt divided by p2 set. So that is 1.013 divided by p2 set is given 0.665 bar, 0.665. So in the option you can see that gamma 1 will be less than gamma 2. So gamma 1 is less than gamma 2. Which of the following option is correct? Only one option is incorrect, that is B. So directly without calculating these things, you will get to know that which of the following, I mean from the option first. This is the trick. Second thing is you are supposed to calculate the Van Laer coefficient. Okay, so now you have calculated the value of gamma 1 and gamma 2. I think here you have to calculate, and without calculation also you can substitute this value in option and you can calculate. So x1 x2 you know, because here x2 is given, you can calculate x1 also, and once you calculate x1, so x2 x1 you know, ln gamma 1 gamma 2 you know, and directly you can calculate the value of A and B. Is that clear? Okay, this was also a good question, but again if you know the tricks, then definitely this question will be very easy for you. Again, this question looks very difficult, but again let's say how we can solve this particular problem. And in a previous lecture also I have solved this kind of problem. So consider a binary liquid mixture at equilibrium with its vapor pressure. Okay, so here you can see that Antoine equation is given in the form of log base 10 and pi set. So this is the crux point here. You have to understand A minus B upon T plus C, where temperature in degree centigrade here. Just don't convert into Kelvin, right? And temperature directly you can now substitute log 10 pi set, that is equals to A minus B divided by directly 25 plus C. And ABC of all of these component is given for. So you can say log 10 P1 set, that is equals to 7 minus 1210 divided by 25 plus 12 06 1206. So from here you can calculate the value of P1 set, and again for log 10 P2 set, that is equals to, you can write 6.5 minus 1206 and divided by 25 plus 223. So from here also you can calculate P2 set. Once we have calculated the value of P1 set and P2 set, you are supposed to calculate the mole fraction of component 1 in liquid phase is this, then the mole fraction of component 1 in vapor phase. So if you see the equation, y into pt, that is equals to gamma 1 x1 p1 set, because this question is given for the non-ideal solution. So you have calculated p1 set. Now p total is not given to, is that clear? Okay, so if p total is not given, then directly we can calculate y1 into pt and again y2 into pt gamma 2 x2 p2 set. If we'll add equation first and second, so we can get total pressure, that is equals to gamma 1 x1 p1 set plus gamma 2 x2 p2 set. So finally we can calculate y1 equals to gamma 1 x1 p1 set divided by gamma 1 x1 p1 set plus gamma 2 x2 p2 set. So if I'll divide by numerator and denominator by gamma 1 x1 and p1 set, so I'll be getting y1 equals to 1 upon 1 plus gamma 2 divided by gamma 1 x2 divided by x1 again p2 set divided by p1 set. It's very simple now. So p2 set, p1 set we know, x2 x1 we know. Now the question is x2 x1, sorry, gamma 2 and gamma 1. How can we calculate the value of gamma 2 and gamma 1? So you have been given ln gamma 2 is equals to x2 square 2 minus 0.6 x1, and again you have been given ln gamma 1, that is equals to, this is gamma 1 and this is gamma 2, that is x1 square into 1.7 minus 0.6 x2. Let's say this one is equation first and this one is equation second. So if I'll subtract equation first and second, I can write ln gamma 1 divided by gamma 2, that is equals to x2 square into 2 minus 0.6 x1 minus x1 square into 1.7 minus 0.6 x2, something like that. Okay, so if you'll do the calculation here, it's very simple calculation. Now ln gamma 1 by gamma 2, so 2x2 square minus 0.6 x1 x2 square and again minus 1.7 minus 1.7 x1 square and plus 0.6 x2 square x so just wait once, x2 x1 square x2 x1 square. So if we'll again do the simplification, I can write ln gamma 1 by gamma 2, that is equals to 2x2 square minus 1.7 x1 square, and if I take common 0.6 x1 x2, so you can say x2 minus x1, something like that. Okay, so you know the value of x1 and x2 directly, and you can calculate the value of ln gamma 1 by gamma 2, and from there you can calculate the value of gamma 1 and gamma 2. Once you will substitute these things value, you will be getting this value of mole fraction of first component into the vapor phase. Is that clear? Okay, so these kind of questions are very very important for examination, so you should know how to solve this kind of problem. Okay, then I'll be moving towards the next question of the last question of this solution thermodynamics PYQ. So the question said that G denotes the Gibbs energy of binary mixture, and T denotes the total number of moles of MUI chemical potential of ith component, and G by NT the correct variation of G by NT at constant temperature and these things. So when we talk about G divided by NT, so that used to be equals to x1 mu1 plus x2 mu2. So when G, we talk about G by NT, so if I write x1 mu1 plus 1 minus x1 mu2, so you can write G divided by NT, that can be written as If I take common x1, so that will be equals to mu1 minus mu2 plus mu2, right? So let's say this one is equation first. When x1 is equals to 0, what will happen? Z divided by nt, that is equals to mu2. And when x1 tending to 1, z divided by nt, that is equals to mu1. Is that clear? That is equals to mu1. So if you plot this curve, then this curve should look like in this way. So if on y-axis, if on x-axis, if this is x1, and if on y-axis, if this is z by nt, so this should go like that, a straight line, and something like that. So this value when x1 will be equals to 1, when x1 will be equals to 0, and this value is your mu2 and this value is your mu1. So now you can see from your option so option C is the correct option. Is that clear? That's it. This was just analytical things, analytical things that was required to solve this kind of question. If you know this particular concept here, so definitely you will be able to solve this kind of question. This was just a equation of a straight line, and how you can align the equation of a straight line in terms of slope and intercept, something like that. Okay, so again, these kind of questions becomes very important when you are practicing for the gate examination. So again, you will see these kind of concepts can be used to solve new kind of questions in the gate examination. Okay, so with that, I would like to end this lecture here only, and in the next lecture we are starting with the distillation mass transfer operation from PYQ. So I'll request you to go and try to subscribe my channel, and as well as try to share in your groups, and as well as try to share as much as possible, so that I'll be getting more subscriptions over here, so that it will motivate me to make you more and more video with quality of content. Okay, thank you all.